so. And I want to kind of start by drawing this idea that one of the things that we will see in our study of chemistry is that knowing how many moles of something we have is very useful. By the way, I haven't introduced something yet, but when we use the lowercase n, if we ask for n, that is the number of moles. And we measure it in MOL. So what we've learned is that this is a useful piece of information, because if I know how many moles, I can actually figure out the number of atoms or the number of molecules. You know what I mean? And what number helps us with that? If I know how many moles I have, how can I figure out how many atoms or how many particles is that? How many is a mole again? Remind me. We just said it. 6. Yeah. So if I know that I have 2 moles, I'd know that I just have to double that. If I have 8 moles, I'd have to multiply that by 8. And if I know how many particles, I can figure out how many moles, right? So I can always go back and forth between these. But what we then learned a couple days after that is if I know how many moles of something I have, as long as I know what it is, I can figure out how much that should weigh. I can find what's M stand for? It's mass. And I can figure out its mass, and what do we measure mass in? Grams, that's right. And what information do I need to know that? Well, I just need to know how many grams are in a mole. Where do I find that information? Where do I find how many grams are in a mole of something? Yeah, the periodic table. If I look at the table of the elements, it tells me how much a mole of anything weighs. If I look here, it tells me that iron weighs 55.845 grams. So if I know how many moles of iron I have, can I figure its weight out? Mm-hmm. Sure. Does that make sense? And likewise, if I start with this information, I can figure out how many moles. Does this make sense? This is what we've basically learned so far this unit. This mole is going to be the central unit, because what we're going to learn is that once I know how many of these I have, there's actually a lot of stuff I can figure out. So today we'll talk about the other thing we can figure out. And to do that, I want to start by introducing the topic. What we're learning today is called stoichiometry. Stoichiometry. Let's all say it together. 3, 2, 1. Stoichiometry. That was not very good. Let's try it again. 3, 2, 1, go. That was somehow worse, which seems improbable. I'm going to try it one more time before giving up on you forever and deciding that you're incapable of a simple task like saying stoichiometry. 3, 2, 1. Wow. I weep for humanity. Let's carry on. So, stoichiometry is the ratio of atoms involved in a chemical reaction. And I quickly want to look. We have a chemical reaction here, a very simple one. If you take water and you apply some electricity to it, what can you get it to do? Yep. And what's it making? And what kind of a reaction is this? It's a decomposition reaction. Good. So balance this. Come on. It should take you 2 seconds. Balance that reaction. Yeah, looks good. Well done. How we doing? How we doing? Good. All right, so let's take a look here. What isn't balanced right now? What's out of whack?
I don't know.
Well, how many hydrogens do I have here?
2.
How many hydrogens do I have here? All right, we're good. How many oxygens here? How many oxygens here?
2.
Oh, no. So I need more oxygen over here. So what can I put in front of those so these will balance? Good. So do that. but what does that make not work now? How many hydrogens do you have here now?
4.
Good. So what do I need there? Beautiful. Good. Does that make sense?
Sure.
Sure, yes. Ish?
Yeah. I don't understand balancing equations. So.
That's good to know. So we'll get some practice in on that. Because once you get it, you'll get it. Just need a bit of work with it. The trick is to just honestly look at it and say, before we put a number there, how many of these do I have? 2. How many do I have over here? 2. They balance. They're good. 1 oxygen, 2 oxygens. The only place I can put a number is in front. We just multiply it by. With a bit of practice, it'll come. All right, let's take a look up here. Guys, I appreciate your enthusiasm, but today's a key one. Let's make sure I got you up here. How do I balance this? What is out of balance to begin with? Oxygen. So what do I need here? What does that put out of balance? So what do I need here? All right, and then this, we normally wouldn't write it, but I'm going to write it for now. I'm going to say we have 1 oxygen. Though again, in a normal setting, we wouldn't write that. So if I say this in words then, what I know is that in this reaction, how many water molecules do I need? 2 water molecules will decompose, which makes how many hydrogen molecules? And how many oxygen molecules? Good. That's what this equation is saying. That if I take 2 water molecules and decompose them, I get 2 hydrogen molecules, but I only get 1 oxygen molecule. Everyone see that? So then, from that, we can derive what we call the stoichiometric ratios, which sounds fancy, but it just means when you look at an equation, there are ratios we can find here. For example, when I look at this equation, I see that for every 2 water molecules I have, I must have 2. Now, again, look here. Am I going to count things in molecules in the lab? No. In fact, we use a lot of them at a time. What is my counting unit for these things? Not grams. Gram is a weighing unit, but it's not counting. If I have grams, I don't immediately know how many atoms I have. What's our counting unit? A mole. Good. So here's what I could say. In this reaction, there are 2 moles of water for every 2 moles of hydrogen gas. Does that make sense? That's a ratio from this reaction. For every 2 moles of this I get 2 moles of that. If you wanted to write that in lowest terms, by the way, you could, but I don't. I always just grab the numbers straight from the reaction. So even though, could I write this as a lower ratio? I could say that is a 1-to-1 ratio, right? But I don't care. I always just grab the numbers straight from the equation. If you like lowest terms and you want to express it in lowest terms, you go nuts. That's great, but I'm not going to. Who can give me a different ratio that I could get from this equation? Any ratio. Another stoichiometric ratio that's true from this reaction. Yeah, what do you got?
For every 2 moles of water, there's 1 mole of oxygen.
Good. For every 2 moles of water, I get 1 mole of oxygen. Yeah, that's true. Who can give me a different one? By the way, it doesn't matter which one I put first. I could say for every 1 mole of oxygen, I get 2 moles of water. That's true too, right? Same information, just expressed in the opposite order. That's fine. What's another ratio I could put there? Any ratio that is true from this reaction. Yeah. Very good. For every 2 moles of hydrogen, we get 1 mole of oxygen. So I can grab any ratio from this that I want. And obviously, as the reaction gets more complicated, there's tons of ratios I could pull out, right? This just has 3 elements to it, so it's fairly simple. But does this make sense? It doesn't matter which one I put on the top, which one I put on the bottom. I'm just looking at this reaction and saying, for every blank number of these, I have to get blank number of those. You can compare any 2 things you want. If I looked at this and compared oxygen to water, what's the ratio? Well, for every 1 mole of oxygen, I have to start off with 2 moles of water. Does that make sense?
Oh,
Okay. Well, to make it analogous, you could think about a person. You could make stoichiometric. I don't want to talk over top of people. Thank you. We could talk about the stoichiometric ratios of a person. For example, if we look at a typical, and obviously there's exceptions in every case, but if we look at a typical person, for every 1 nose, they have, 2 nostrils. Great, give me another ratio. On a typical person, for every 2 ears, they have
1 head.
1 head, sure, perfect. Most people, only 1 head. Most people, 2 ears. For every 10 fingers, a person has 2 arms. You could pick any 2 things you want and just make a ratio of it. Does that make sense? You could say for every 2 ears, a person has 10 fingers. There's another ratio. You could think of it this way. If you want to build something, you need to know the ratio of stuff you need. If you're building a car, if I'm building a car, for every 1 steering wheel, that's all I need to build a car, just 1 steering wheel. How many wheels do I need?
2.
Yeah, on a typical car, 4, right? And listen, if you get that mixed up and you have 4 steering wheels and just 1 wheel, you're going to have a not very effective vehicle.
But the steering
Right?
wheel could be the wheel.
Does that make
The
sense?
wheel could be the
So that's the
steering
ratio. We go back to that car analogy. For every, most, if your car is like mine, it's got like 2 seats in the front, right? And they're probably the exact same piece of, all the same fabric, all the same steel frame and everything like that. They're pretty much identical. They're actually probably not perfectly identical if they have if they have hand-controlled adjustments, because on one of them those adjustments will be on the left side and on the other they'll be on the right. But if we set that aside, for every 1 steering wheel, if I'm building cars, I gotta have 2 of those front seats, right? Does that kind of help it clear it up? You're just making ratios. And in this case, we're looking at a chemical reaction. And this chemical reaction requires 2 waters. You get 2 hydrogens, but you only get 1 oxygen. And I can make any ratio from that I want. So the point of that is, when the time comes that we are thinking about a reaction, we are going to use the ratio that makes sense for what we're talking about, right? In other words, if I work in the car factory and I'm the guy responsible for steering wheels, my ratio is easy. For every 1 car, I need to make 1 steering wheel. That's the ratio I'm interested in, right? If I'm the guy responsible, on the other hand, for putting together the engine, I might know that for every camshaft, I'm going to need 4 pistons, or 6, or 8, or whatever the case may be, right? Depending on the design of that vehicle. A lot more complicated ratios there, right? I might know that for every valve, I'm going to need 1 inlet valve, 1 outlet valve, all these different ratios. Chemistry, we're going to be comparing the different elements of a reaction, which, by the way, you'll hear me use a word once in a while, species. Sometimes we talk about each of these being a different species in a reaction. You might hear me say reactants, products, chemicals, whatever. It all means the same thing. We're going to talk about these different things. So, I do want to make a note. It doesn't matter what you put on the top. It's just as true to say for every 4 wheels on a car, there's 1 steering wheel, as it is to say for every 1 steering wheel on a car, you need 4 wheels. Do you see how it doesn't matter which one I say first, which one I say second? It's the same ratio. And in chemistry, we're going to put the one on top that we want to put on top, so our units, that's our new unit. We're going to put the one on the bottom that we want to get rid of, because the bottom is where we put units we try to cancel, right? So that's how in chemistry we're going to pick which one goes on top and which one goes on the bottom. We're going to do it by setting up our dimensional analysis. Does that kind of make sense? A little bit? I'll take a little bit for now. So instead of trying to explain it away, we're just going to do a couple examples together, probably 3 or 4 examples together. Then I'm going to send you off to do your own. And we're going to start with a nice, easy one. So if we remember this reaction, we're going to say that 2 moles of hydrogen dioxide, which is a liquid, and I said it wrong, it's dihydrogen monoxide, react to give us 2 moles of hydrogen gas, and to give us 2 moles, or not 2 moles, 1 mole of oxygen gas, right? I'm struggling here. Did I get that put down correctly? Okay. Except I'm told here that how much of this stuff do I actually have? Yeah, I've got 2.3 times 10 to the negative 3 moles of this stuff. Can everyone see that? Which I could write this way. I could say 2.3 times 10 to the negative 3 moles. Or if you wanted to, if you hate scientific notation, how many places do I have to move this decimal to make this not scientific notation? 3 to the left, so I could go 1, 2, 3, and I could write this as decimal 0023. Yeah, either or. Does that make sense? Which would you rather do for this first example? You're fine with scientific notation? Is everyone fine with scientific notation? You guys are good. You guys are tough. Like me. I'm tough. It's one of the first things people notice about me. All right. So we start out with that many moles, but that many moles of what? Of water. Okay. When I do dimensional analysis, I always draw a fraction. And what unit do I put on the bottom of that fraction? Yeah, the unit we're getting rid of. In this case, what don't I care about? I don't want to know how many moles of water. What do I want to know? Yeah, I want to know how many moles of hydrogen gas. So where am I going to put that? On top. Now we're starting off with a very easy question. In fact, you didn't really need to do dimensional analysis to answer this, did you? Because look at the reaction. Can anyone tell me, doing exactly no math whatsoever, if I know how many moles of water I'm starting with, do I know how many moles of hydrogen I'm going to end with? Yeah, because the equation actually tells us, what do we notice? It's just the same number, isn't it? So this is not a very exciting answer. So if I started with 5 moles of water, how much hydrogen would I get? If I started with 10 moles of water, how much hydrogen would I get? If I started with 2.3 times 10 to the negative 3 moles of water, how much hydrogen am I going to get? Good, right. So the math here is pedantic, right? We know the answer is going to be 2.3 times 10 to the negative 3, but I want to show you how it works mathematically. I want moles of H2O to cancel, because that's not what I want to talk about. So I put it at the bottom. Now those units will cancel. I put the unit I want, moles of hydrogen gas, on top. And now I have to get numbers for here. Where do we get those numbers? That's the trick. Which is, here we need the stoichiometric ratio, which sounds fancy, but really it just means look at the chemical equation. Just look at the chemical equation and take the numbers right from there. In this chemical equation, how many moles of hydrogen do I make? 2. So I'm going to put that number there. I need a new color. There's a color. And how many moles of water do I use? Does that make sense? Tell me if it doesn't. But right now, we're setting up a question that's very, very simple. But when we get to tricky questions, this is going to see us through. So what we can say now, we always start with what we're given. We multiply, we say the unit I don't actually want to talk about anymore, I cancel that. The unit I want, we put up top. Again, this question's pedantic. It's really simple. But when we get to tricky ones, it's going to help us. By the way, what is anything if we double it and then also divide it by 2? Yeah, it's basically timesing it by 1, so the answer, without even needing a calculator, is going to be... Except now it's not moles of water, now it's moles of hydrogen. And again, I would not mind in the least if you did this question in your head, but we'll get to questions coming up, I promise, that you won't be able to do in your head. So we want to learn the skill here. Does this basic process make sense? We need a balanced chemical equation. You can't do this without knowing what the balanced chemical equation is. Early on, I'm going to always give you the balanced chemical equation. But then once we get a bit more comfortable, I'm going to not give you the balanced chemical equation, and you'll have to figure that out. That's going to be a part of the question. All right, let's look here. How many moles of oxygen gas are produced if this much grams of lithium oxide are decomposed? Oh my God. Let's get to it. The first thing we need, always, is you need a balanced equation. You must have a balanced equation. So in this case, what am I decomposing?
Lithium oxide.
Lithium oxide. So let's talk about lithium oxide. What's its formula going to be? What charge does lithium take? +1. What charge does oxygen take? If I had one of each, do I get a balanced chemical? But if I have two lithiums, all of a sudden it works. So what's the formula of this thing? So you see how those old skills don't go away? You're going to use them every day, every question. And what are we doing with this? We're decomposing it. What's it mean to decompose? That's going to break apart. So when this breaks apart, what am I going to get? The only thing I can get is lithium and oxygen. Okay, it's a gas. And that's a solid. And I'm going to assume this is a solid too. We're good? Oh, and that should be 2 too, right? Oh, the 2 should be inside, right? Like that? Right, why isn't it Li2? Yeah, because I'd be changing the formula. Lithium is not diatomic, right? So I can't put the 2 down there. And now we need to balance this. And this doesn't balance too difficultly, but it's a little confusing because my instinct might be to say, how many lithiums do I need? Cool. But am I done? No, because how many oxygens here? How many here? So I need like that. So I need like that. That? Okay. But what did that do? Now I need 4 lithiums. All right, so there we go. We've got our balanced chemical equation. And again, if balancing equations are giving you trouble, that's okay. Just make sure you get some practice with it because it's not going away. Again, today I'm going to help you balance all the equations. That's fine. We'll do that together. But going forward, you'll have to do it yourself. Once you balance the equation, we're going to get going, right? Which is, what do I want to know in the end? How many moles of oxygen gas? So my answer, I like to think about this. My answer is going to be moles of oxygen, right? What am I starting off knowing? Yeah, very good. I start off knowing grams of lithium. Now let me ask you this. Is there a quick way to go from grams of one thing to moles of a different thing? That doesn't make any sense, does it? Like, that would be like saying, well, I know I've got 3 pounds of ground beef here, so how many hamburger buns is that? Do you see what I mean? It doesn't make sense, does it? I could figure it out. I could figure out how many patties that'll be and then figure out how many buns I need. But before I can figure out how many buns I need, I'd have to figure out how many patties that is, right? Does that kind of make sense? Am I the world's worst teacher at analogies? Was that one okay? Ha! Look at me. Okay. I'm getting it. So before I can figure out how many moles of oxygen I need, I'm going to have to figure out how many moles of lithium that is. Does that make sense? And do you see, I like to do this where I kind of map a question out in my head. You don't have to do this. I will never make you do this. But this helps me go. Because now I look and say, okay, once I know how much lithium... a lithium oxide is what I start with, isn't it? Yeah. Like that. That's okay. Once I know how much of this stuff I have, is it hard to figure out how much of this I get? It's actually pretty easy, isn't it? Because I know, look here, if I had 2 of these, how many of that do I get? Look closely. 2 of these will give me 1 of those. Can we see that? No number in front means 1. If I had 4 of these, how many of that would I get? If I had 20 of these, how much of this would I get? If I had 200 of these, how many of these would I get? If I had 2,000 of these? If I had 2 billion of these? Does that make sense? So once I know how many of these I have, it's very easy to know how many of these I have. So that's a step I can take. Do you see what I've kind of done here? I've mapped the question out. You don't have to do that, but I do it every time because it helps me know what I'm going to do. I'm going to start with my given, and before I figure out how many moles of oxygen I have, I'm going to have to figure out how many moles of the stuff I was given I have. And we're going to do that using dimensional analysis, which means I'm going to start by writing down what I'm given. So in this case, what was I given? By the way, if you wrote this like really big and you're like, oh, I wish I hadn't written that so big, you should probably just like highlight it, shrink it down a bit, move it up, maybe down a bit again. Like right there, just make sure you've got it exactly where you want on the page, is all I'm saying. You're smart. You'll figure it out. All right. How many grams of lithium oxide do I have to start with? Yeah, 3.4 times 10 to the 3. And you know what? Like maybe I don't want to, just to show you if you hate scientific notation, let's do this one by changing it. So 3.4 times 10 to the 3 would be 3.4, but how many places am I moving that decimal? So 1, 2, 3. And what goes in these empty spaces? And so this number is actually what? Yeah. You don't have to do that. In fact, eventually I think you won't do that. But I just want to show you that you can. Is that comfortable? And that's grams of what? Yeah. And this is where you're going to have to become a dedicated writer of units. You can't just say grams, because grams of what? This question doesn't just talk about one thing. It talks about 3 different things, right? So I got to know what you're talking about. And I know that the central unit, what we are always going to convert to in this class, when in doubt, figure out how many moles you have. When in doubt, figure out how many moles. So what do I want to cancel here? Grams of lithium oxide. And instead I want moles of lithium oxide. Now, unfortunately, lithium oxide is not on the periodic table as its own thing. So what am I going to have to do? Yeah, we're going to have to add it up, but that's okay. So I usually would just kind of grab a little sidebar here and say, okay, lithium oxide is going to be what? It's going to be 2 times 6.941. Where am I getting this number?
From the periodic table.
From the periodic table. Plus, what else? Oxygen is, yeah, 15.9994. If you said 16, that's fine. And can someone do that? Like real quick, that's going to be 14 plus 16, so that's what? That's 40? It should be roughly 40, but I need an exact number. It'll be 39 point something.
39 point.
Come on, someone, help me out here. We're losing time here. This is the easy stuff. Everyone should be shouting an answer at me, and yet nobody is shouting an answer at me. I don't know why that is.
Figure it out, you're smart.
I got news for you. I already have this credit. And the next one. And you're right, I'm smart. I'm getting paid right now. Are you getting paid right now? All right, give me the number. What do we got?
It's 29.8.
29? Oh, I can't even add. Maybe I'm not smart. Maybe all this time. 29 point?
Sorry, I'm just doing this.
I trust you. No, you're good. I just can't add. You're fine.
8814.
There we go. All right. So now when I go to put that number here, where's the number go? Help me out. Do I want to put it in like this? Is that correct? Yeah. And say it out loud. 1 mole of this stuff weighs about 30 grams. Right? As opposed to, if I put it the other way, I'd be saying 30 moles of this weighs a gram. That doesn't make sense, right? So we like that. And here's a phrase you're going to hear me say a million times. If I stopped this question now, what would I know? Well, what units would cancel right now? Grams of lithium would cancel. So what would I know if I did this math? I'd know how many moles of lithium oxide I have. Good. Except, and that's what we did all yesterday and stuff, right? But now the question isn't how many moles of lithium oxide. The question is, but you've already told me. Remember you told me that if I had 2 billion of these, how many of these would I get? 1 billion, right? If I had, ready? If I had 48 of these, how many of those would I get? Good. Oh, you guys are good. You're quick. So the last step then is I need to cancel moles of lithium oxide, and what do I want instead?
Moles of oxygen.
Moles of oxygen. So I'm going to cancel moles of lithium oxide, and instead I'm going to say moles of oxygen. Does this make sense? And now, where am I going to get these numbers? Well, you just told me. You just told me that if I had 2 billion lithium oxides, I'd get 1 billion oxygen. Where did you get those numbers? Yeah, from the balanced chemical equation. And specifically, we know that 2 lithium oxides give me how much oxygen? 1 oxygen. Does that make sense? It's a little clunky at first. At least when I first learned it, I found it a little clunky. But once you get the hang of it, you'll find that I promise, you'll find that it's very intuitive. There is another way to teach this, which is some teachers give you 3 or 4 different equations that you can use. And then you have to memorize these equations. And maybe they teach you like the triangle where you like cover the thing you're not looking at. Have you ever seen that? Teachers show that. Don't worry about it. And then you have to be like, what equation am I using? What does that letter mean again? This way, we don't do any of that. We just say, I'm going to talk my way through it. I think this is actually a little trickier to learn at first, but once you get it, it's so much more powerful. Because the thing is, even if you use the equation, at some point you have to do this. At some point you have to think in terms of ratios and say, oh yeah, for every 2 of these, I get 1 of those. So if you're going to have to do that at some stage anyway, why not treat the whole thing like a ratio? And that way we just talk our way through it. So to back up and talk my way through this, I started with 3,400 grams of this stuff. But even though I can weigh that out on the bench, that helps me in real world, an equation doesn't deal in masses, it deals in numbers. So I've got to turn this into a number. Counting number is the mole. So I don't want to know how many grams I have, I want to know how many moles I have. Luckily, I know that 1 mole of this stuff weighs 29.8814. And then I say, okay, but I don't want to know how many moles of that stuff. I actually want to know how many moles of oxygen I'm going to get. But I say, that's no problem, because I know from the equation that for every 2 moles of the stuff I just counted, I get 1 mole of the oxygen that I'm actually interested in. That's what this ratio set is saying to us. Don't treat it like a blind thing. Talk your way through it. And that's a muscle you flex, all right? It's a skill you have to develop. And how do you build muscles? And don't I know it? Yeah, that's right. You show them off. Is you just do it repeatedly, right? You want to look like this, you've got to work at it. You got to go home and be like, I'm not hungry. And you'd be like, no, you are hungry. Eat the bread. Eat the bread. And that's how it works. All right, somebody actually do this in the calculator. This is going to be on the order of like 100 divided by 2 again. This should be on the order of like 50.
57.
What is it? 57? All right. 57 point. All right. And you're right. So 57, what's the unit here? What unit canceled? What's left? Moles of what? Good, because these cancel and we're left with moles of O2. And Ms. Rutledge very cleverly rounded this to 57. Why did she round it to 57? That is what I want you to do. Why do I want you to do that? How many sig figs here? 2. Those zeros, the placeholders. I don't know if they count. How many sig figs here?
Uno.
Is it 1?
Oh, no, it's infinity.
It's infinite, yeah. How many here? 6?
Yeah.
How many here?
Infinite.
Infinite and infinite. So I need to have 2 sig figs in my answer. Does that make sense? Questions?
Wait, is there such thing as 1 sig fig?
Sure.
Really? How? What would it look like? 0.1.
Sure, yeah. Yeah, definitely.
But wouldn't that be... Okay, wait.
Those are all 1 sig fig. Does that make sense?
Yeah.
Yeah, beautiful. How is that? It's not too bad, is it? Now, the next one, we're going to go even one more step. All right? I'm just throwing you to the wolves. We're just going to do worst case scenario, which is I'm going to tell you how many grams of this we get, and I want to know how many grams of something else we get. We're going to go from grams of one thing all the way to grams of something else. Oh my God. But if you look back here, remember that the central unit, the thing we're always going to convert to is how many moles. Because also remember, once I know how many moles of one thing, I can know how many moles of something else. If I know how many moles of oxygen, I can figure out how many moles of copper. So here, we're going to sketch this question out, we're going to get the balanced chemical equation, and then you're going to do the dimensional analysis. All right? So talk to me. What's the reaction here? What's the reaction? What are we reacting? Good. By the way, what do I mean by excess? That's weird. Yeah, I just got lots. I got more than I need. I'm not going to run out. Does that make sense? Because when I say 3.2 grams of solid copper, when I say I have enough oxygen, I just mean we're going to use all of that copper. We're not going to leave any of it behind. Does that make sense? All right. So I have copper. What's the formula for copper? And what's it going to react with? Like that? O2. Good. And what am I going to get? Yeah, now there's two possibilities here. We're just going to stick with one of them. And let's make life easy. Let's just say that. Is that copper 1 oxide or copper 2 oxide?
Copper 2.
Very good. All right, balance this for me. Nice, easy one.
Put a 2 in the copper, or in front of copper, and put a 2 in front of the copper oxide.
There we go. All right, does that make sense? Now, let's sketch this thing out. What information am I given to start with?
2 grams of solid copper.
Good. So I know how many grams of copper I have. What do I want to know at the end?
Grams metal oxide.
What's the metal oxide in this case?
Copper.
Cool. What am I going to have to figure out in the middle? Is there a way to go from this directly? Can I say that if I have 2 grams of this, I'll get 2 grams of that? Does that make sense? Does a balanced chemical equation tell us about weights? It tells us numbers, right? In fact, that doesn't make sense. This has obviously gotten heavier, hasn't it? Because it's got oxygen stuck to it. So you have to remember that a balanced chemical equation can't tell you how many grams of something you get. It can only tell you how many. How many? Yeah, and what do we count that in? Yeah, don't be shy. So I can go from grams of copper to moles of copper, right? And if I know how many moles of copper I have, now can I know how many grams of copper oxide I get directly? Directly?
Oh, no, it's right.
What do I have to figure out first? Well, not for this question. Right, like you're right, except the question doesn't actually ask me about oxygen, so I'm going to ignore it. It does want me to know how much copper oxide I get. So I'm going to figure out how many moles of, and by the way, this is easy. If I have 2 moles of this, how much of this do I get? 2 moles of this, how many of these do I get? 2. If I had 7 of these, how many of those will I get? If I had 53 of these, how many of these will I get? 53, indeed. If I had 2 billion of these, how many of these would I get? Can I please stop doing this? Yeah. We get it? All right. And then once I know how many moles of that I have, then I can figure out how many grams. Wow, this is a 1, 2, 3-step process. Longer than the last one, which was a 2-step process. But you know what? I have faith in all y'all. So get to it. All right, get on it. Do your best. We'll take it up in a couple of minutes, but I want you guys to do this one. You can do the dimensional analysis. Just remember, 1 step at a time. Think about units first, then think about numbers. Units first, numbers afterthought. Yeah. I believe they call it male and calorie. Yeah, that's just a quick, it's called mail and calendar. So it'll show you your mail and your calendar, like you do with your calendar. Get it? That's all that, right? I shouldn't need to pass this.
Shut up. Scully don't know.
Scully don't know.
So annoying about it. I like to last year. Now she's like, I'm still here. And I'm like, no, I really don't.
Really?
No, I
Who
actually.
do you like it?
Huh?
Who do you like?
I don't like anyone. Nobody meets my stalkers.
Not even
Good.
you? She might stand there because she's a 5'.
Maybe.
And now, this one has the CSPN account. Oh, it was already there. It was already there.
Sorry, it's
No, that's the one.
you don't get it.
It's actually a great little app because, in fact, I would recommend hitting it because it has all of your mail. Yeah, now it's not good for groups. So when you want to look at your group stuff, you still have to go into the other. But for just real quick sending and getting an email, way easier. So now it's got this stupid focus box, which I absolutely hate. Yeah, so there you go. You got all your emails. And I joined the school calendar. We'll actually pop that up too, which is nice. And then now, if you send a message in here, you can go inside. Now that your pen is up. I'll look at that. I wonder if you have to update it, or I can have it on here. It might just not be aware that you have a pen installed on it. I'll look into that. I will have it set up for you in no time. There should be a thing right up here that says draw.
Oh.
And there's just a tick box I have to put somewhere. Oh, I think I know what it is, in fact. Yeah, like there's just one thing we have to say. Yeah, I'll do that. I know there's just a simple thing where we say yes, enable that.
What's it called?
It'll just say draw up there.
Okay.
But I've got to, it's somewhere, it's in like the Windows system saying there's a little thing where you have to say like allow pen inputs.
Okay.
Yeah, I'll get it.
Put arrows here, like direct.
No, I wouldn't.
Or just.
You can. If it helps your thinking,
Okay.
if it helps your thinking, then yes. Like absolutely. And what do we got? What do we got? Start going.
Not 83. We can't read that. Yeah.
Oh, well, you have your own, don't you? Like the one, yeah, grab that. Here,
We're going to.
yeah.
We
You're
were just
clever.
trying to figure it out.
We're just trying to, from first principles, guess what the,
Yes.
were you just shouting numbers across and saying, Richard, is this right? And then he said no, and then you try again.
And then he just ignored us.
Ah,
Yeah.
what a guy.
Right?
I think it says 63.546.
Whoa, I saw 83.
Well, I mean, you're younger than I am, but
I'm also blind.
you got glasses on. I don't have my glasses on. But I have more trouble reading up close than far away.
This is blind in general.
How we doing? That's okay. That's okay. Put grams of copper here.
Here.
That's okay. Yeah, put grams of copper. That's good. Yeah, that's good. Okay, now multiply by a fraction. We're always going to multiply by a fraction. Now here's the thing. We know that eventually we want to know how many moles of this stuff. Problem is you can't go from grams of one thing to moles of something else. So you have to go to grams of one thing to moles of that same thing. Does that make sense? It's the only thing you can do, because that's on the periodic table. So if I know how many grams of copper I have, I can figure out how many moles of copper I have. And in this course, when in doubt, figure out how many moles you have. It'll always help you. Always, always. So I want to figure out how many moles. So where am I going to put grams in this? Cool. Show me that. Yep.
So 3
Not through, never numbers first. Just
Okay.
units first, then we put numbers in. That's the whole trick, is to think about units first, grams of what? Yeah. And we're going to figure out how many. That's right. And specifically of copper.
Did I just do that?
Yep. Yeah, that's beautiful. Now, the nice thing is to know how many grams are in a mole of something. That's what the periodic table tells us. We call it the atomic weight. So let's look at copper. And copper weighs how much?
63.
Cool. So you can put that, 63.55. But where's that number go?
Here?
Yeah, I like that, because we'd say that there's 63.55 grams of copper.
Yeah. Because it's a weighing number.
That's right. In a mole, right? And what's the number for a mole? When we say there's 63.55 grams in a mole, we mean in 1 mole. Does that make sense?
Yeah.
So you can put 1 up there. Cool. So now, if I stopped calculating now, I would know how many moles of copper I have. Does that make sense? Because grams would cancel with grams. That's okay. It's tough. It's like me. It's mine. It's got to be tough. I'd know how many moles I have. But I'd know how many moles of copper. Eventually, I need to know how many grams of the copper oxide I have. So, I got to keep going. Does that make sense? So cancel the units that cancel. Put a line through them. So we can see, like, okay, I've got moles of copper. Now draw another fraction.
Should I?
Yeah, multiply, and then another fraction. And you won't need a long one here. That'll be plenty. We want to cancel moles of copper. So where's it going to go? Good. And because I want to know how many grams of metal oxide, but before I can know how many grams of metal oxide, I have to know how many moles of copper oxide. So let's put moles of copper oxide up here.
Moles.
Yep.
Yeah.
I would have made the same thing. I don't think it's right.
Good. And now we have to figure out these numbers. Well, from the reaction, in this reaction, how many moles of copper do we use? Good. So put that with moles of copper. Good. How many moles of copper oxide do we get? Good. So put that with moles of copper oxide. Now let's cancel the units that cancel. And I'll ask the question I always ask. If I stopped calculating now, I would know how many moles of
Copper oxide.
Good, very good. The problem is the question doesn't say how many moles, it says how many.
Grams.
Good. Can you show me the next fraction? Great. You're doing good. Real good. I do see you back there. I promise I'll get there at some point. And over there. And just calm down. Calm down.
You can go. I'll try to figure it out.
You sure? You sure? All right. And if you don't, that's okay too, but do your best. Worst case scenario, you get wrong. I get things wrong every day. Come back there. I'm coming around. Okay.
All y'all. All y'all.
No problem. So let's start here.
You know more. You know
Now we're going to start with what we given. So what are we given? Yeah.
So if I did any less hard, it wouldn't have come off. Hey, what? I'm not doing anything. I don't think so either.
Yes,
I have
like,
no
like if
confidence.
you add total mass of these together, that's what the total mass of those.
No, I have zero confidence.
Why is your nail so soft?
I just said if you have like half attention.
Not even that. This is how we
That's just balance.
But like a nice big fraction. It's just fraction. No numbers.
What?
Yeah, just make a line.
So soft. What? Is it good?
Now we're going to I don't want that.
Mine are hard.
So before I even look at the question, I know that can go well.
I have no understanding
It would be a very exciting question if we just kept what we have.
The wonderful thing is,
And now we can look at this one. You know how many moles this crap like that.
what I do.
Actually,
I
on
put in
grams
brackets
of
all of this.
Before I do that, you
I
always
do it
have
in
to
a line, but 3.2 grams times 1.
Oh my god.
Oh, let go. Let go.
Heck?
Oh my ew. That's wrong.
Emma, you deleted it.
No, he's getting
Yeah, you deleted it. It's gone now.
Why did you delete it?
Guys, that volume. Keep it down. Keep it down.
But pretty much
Did you delete it?
You deleted it. What the? I forgot I had it.
Emma, or Hannah, why'd you take a shit on your paper?
Good. So put that in there.
How the heck do you do a Z? What? It's a Z.
It's like this. Like,
it's actually 15 points whatever.
damn. Right, it's my math. It's my math.
Math?
Don't touch it. And we're back. Wait, down backwards.
Copper oxide is green.
Is it?
It's not.
Now what cancels?
Copper oxide's green.
Completely remove it. This is times 1.
I know. Fucking stop.
What?
I saw it coming.
There's nothing on
Yeah,
it.
because I just got it off.
I want to know about this.
What do you mean? I didn't touch
Did it
it.
once, do it again.
What? I'm getting blamed for nothing.
Now look at the equation.
You literally had that purple marker thing before I even had markers. You had it in grade 10. I didn't have markers in grade 10. Yeah, like,
How many moles of copper oxide is there? Now cancel the cancel.
Tossed out.
Well, still, you're
Well, they have to match straws and balls.
yeah. So you fix that.
So if I stop calculating that, in the end, what you're doing is there. It doesn't ask how many moles, it asks how many the last one
Divide by that times. Honestly, if you tell me by 2, it doesn't matter.
Are you kidding me?
You want to cancel the place, it goes in here.
So you don't even have to do it.
You want to cancel.
Oh my god, why do you go so red? Holy.
Yeah, because she fucking grabbed my hand.
Oh.
Yes, turn it, daddy. Oh. Okay. Sorry. Abusing. Sorry.
You got that, you good?
It's okay. Push, push, push,
Yeah, I'll pull up.
Because I got it. Different answer.
Lost.
2 words.
Are you lost?
Wait, can you scroll back down for the step? I think I just. I
Steps?
think
Should I
I
delete them?
messed up.
Is that too many?
The problem is, this isn't, there's nothing to cancel here.
Yeah, there
Right?
is.
No.
You end up with
What?
moles.
But look, you have to know moles of what? This is moles of copper. And those are moles of copper oxide. Those don't cancel. They're different things. So before you can, you're going to have to do this. But before you can do this, you have to be talking about moles of copper oxide.
So I just switch them?
So you're not ready for this yet. Do you have that number written down somewhere? Do you know it?
Yeah, everyone knows it.
Okay. All right. So before we can do this, we're almost there, but I don't want moles of copper. I want moles of copper. Does that make sense? Now let's look at the equation. How many moles of copper get used in this equation? Look at the equation. How many moles of copper do we use? Good. Now let's look at the equation. How many moles of copper oxide do we use? Good. Now, what cancels? Well, moles of copper cancels with moles of copper. And grams here cancel with grams there. Now, you're ready for the fraction you just tried to do. Does that make sense? So you're doing great. You just skipped a step. Which, as mistakes go, is not the end of the world. Yeah. Well, we're just about to take it up, but let me take a look at what you've got so far.
But you're not trying to find moles.
No, it's true. And also, this isn't grams of copper oxide. This is grams of copper. So that should be Cu. You're going to need that number later, but you don't need it yet. I know, we're going to take it up. Listen, it's okay to struggle with this a bit. It's tricky. It's tricky stuff. Like a grade 11 university class, or if you're in the college, it's a grade 12 college class. It's tricky stuff, right? So it's okay. It's okay to struggle a bit with it. We're good. Yeah.
I think that's right.
No, I haven't done the math yet. That seems quite high to me. That seems like a really high number to start with that much copper and all of a sudden have that much copper oxide. Right. I don't think I like that number. So I think you missed a step somewhere. Yeah. Well, it's okay. We're going to take it up. And I think you're right there. So just let's go through this, guys. We're going to take it up. Follow along with me. And listen, I can't stress enough 3 things. Thing the first to stress. Talk your way through these. Talk your way through them. I want you cannot treat this like just blindly doing a bunch of math because you won't know what to do next. You've got to talk your way through it. And you're going to make mistakes. When you make a mistake, if you then go, I don't get this is stupid, that's useless. If you go, I don't get this, I'm stupid, that's also not true and that's not useful. Erase it, start again. You're going to make mistakes. All right? I promise you're going to make mistakes. That's okay. It's okay to make mistakes. You just try it again. And you just need to do more. When in doubt, do more. So let's look here. And I'm going to give you lots of opportunities to do more, so don't worry. Let's look here. We always start with what we're given. In this case, what am I given? All right, so that's where I start. I know I've got 3.2 grams of copper. And all I know is I want to figure out how much of this stuff I'm going to get. And the balanced chemical equation will tell me that, but I just have to remember that the equation doesn't tell me that 2 grams gives me 2 grams. The equation tells me that 2 moles give me 2 moles. So when I go to do chemistry, when I go to do stoichiometry, I'm always going to get away from grams, and the first thing I want to do is make sure I'm talking about moles. Always. So I want to cancel grams of copper. So I'm going to do this. Why doesn't this work?
Because the one you want to cancel should be at the bottom.
Yeah, this would give me grams squared per mole of copper, and I don't even know what that means, but I know I can't use it. So I'm going to put grams of copper down here, and I'm going to put moles of copper up there. Now I need a number for this. 63.546. Cool, so 63.546. Where did you get that number? Very good. And how many moles is that? 1. Note, it's not 2 moles of copper. Whoa. This comes from the periodic table, and the periodic table always tells me how much 1 mole weighs. This step will always be 1 mole. Doesn't matter how many are in your reaction. The periodic table tells you how much a mole of something weighs. 1 mole. So this is from the periodic table. What units cancel here? Grams of copper cancel with grams of copper. If I were to stop calculating right now, what would I know?
1 mole is 3.
Yeah, not 1 mole, because that number is not going to be 1. 3.2 divided by times 1 divided by 63.546 isn't 1. But I'd know how many moles of copper I have. Does that make sense? But the question doesn't even ask me about copper. The question actually wants to know about copper oxide. So I know I don't want to talk about moles of copper. So where am I going to put it? I'm going to put it on the bottom. I want to know grams of copper oxide. Is there a place I can look this up? Can I know how many grams of copper oxide are in a mole of copper? That doesn't even make sense. That's back to the hamburger patties things, right? That's like saying how many hamburgers are 3 buns. You know what I mean? There's a middle step needed. So I can't go from moles of copper to grams of copper oxide. I'm going to have to go from moles of one thing to moles of another. Can I tell if I have 7 moles of this, how many moles of that I'll get? I just look at the equation, right? You can always go from moles of one thing to moles of another thing. Where do I look to get that number? Yeah, we look at the equation. And when I look at the equation, if I just say that, does everyone know I mean look at the balanced chemical equation?
Oh, that's what it's
So that was not useful, is what you're telling me. Sorry. Oh gosh, now I'm typing. I'm so sad. Okay, so looking at the balanced chemical equation, in this reaction, how many moles of copper oxide do I use or make? 2. How many moles of copper do I need? 2. Does everyone see that? What cancels now? Moles of copper. And I want pause. When in doubt, talk your way through it. Talk your way through it. Let's talk here. Hey, I start off with 3.2 grams of copper. I eventually want to know how much of this other stuff I get. But the balanced chemical equation doesn't deal in weights. It deals in how many of things I have. So I have to count this. We count in moles. So I don't want to know how many grams of copper. I want to know how many moles. That's okay, because looking at the periodic table, I know that 1 mole of copper weighs 63.546 grams. Now I know how many moles of copper I have. Does that make sense? I'm talking my way through it. Then I say, okay, but the whole reason I'm doing this is I don't want to know about copper. I want to know how much copper oxide I have. But that's okay, because the balanced chemical equation tells me that for every 2 moles of copper, I'm going to get 2 moles of copper oxide. So I can figure out how many moles of copper oxide I need. See, I'm talking my way through it? And then the last step is going to be me talking and saying, okay, but the thing about this question is I don't want to know how many moles of copper oxide I have. I want to know how many grams. So I'm going to cancel moles of copper oxide, and instead I'm going to get grams of copper oxide. And now I need a number here where I just look at the periodic table, right? Because when I want to know how much a mole of something weighs, I just add it up. Now I have to add 2 things together here. Copper is 63.546 and oxygen 16.00, right? So that should be, oh gosh, what did I say that first number was? So it should be 79.5455, 79.55. Your rounding might be different depending on what source you use, but is that roughly correct?
Yes.
Did I put those numbers in the right place?
Yeah.
You sure?
Mm-hmm.
Say it out loud.
Yes.
We keep talking to ourselves and we say, but okay, I get this. It's okay. 1 mole of copper weighs 79.55 grams. Copper oxide, I should say. Does that make sense? I like that. What cancels here? Moles of copper oxide. What's the only thing left? Now I know how many grams of this stuff I have. If you found that you wrote this all a little bit too big, I encourage you just to highlight it and kind of shrink it down a bit and move it. It's kind of like that. And I was able to do that because, as he pointed out, I'm a smart guy. Can we actually do this math? On the face of it, that's going to be like, oh my God, 0.05. 0.05, and then that's going to be 1, and then 0.05 times that. This should be on the order of like 4, more or less. What do we get? Great, and before we round it, what do we get? When I plug this into my calculator, I should get 4.056.
Wait, how do you get that number? Do you just add everything together? Or...
Oh, so let's talk. Well, let's look here, guys. How do I do this? On my calculator, I'm going to start with what number? 3.2, and we're dealing with ratios, so it's all dividing or multiplying. So 3.2 times what? Times 1. And then divided by, and then times 2. Keep talking to me here. Divided by, then times. There you go. Just times the top, divide by the bottom. Times the top, divide by the bottom. Times the top, divide by the bottom. It's not the only way to do it. It's the easiest way to do it. And I get 4.0059. But of course, I have to think about sig figs here. How many sig figs in this question? This number's got lots. It's got 1, 2, 3, 4, 5. But how many should I actually be having here? Is there anything less than 2 here? No, everything else is infinite, right? Or more. So 2 sig figs. So this should actually be 4.3. 4.0. Yeah, and what's the unit? Of? There you go. Now listen to me. This is tricky stuff. It takes a bit of getting used to. What I like about this stuff is that I'm not teaching you equations to blindly follow. Rather, you have to intuit your way and talk your way through this. It is tricky. I don't want you to be discouraged if you find it tricky. That means you're doing it right. It's tricky stuff. You know the only way you're going to get better and get it?
Practice.
With a bit of practice. Practice. And then when you're done that, you need a bit more practice. And then when in doubt, you should spend a bit more time practicing. All right? It's the only way you're going to get better. The only way you're going to figure this stuff out is just doing a lot of them. That's how we do it. Now,
I said,
listen, you've got the rest of this sheet for practice. Tomorrow I'm going to give you more practice. We're not going to rush away from this quickly. By the way, here's a fun thing. We are now ready to do a lab. We finally have done enough math here that we can do a lab on this. Because what should I now be able to do? Look at this lab right here. I should be able to give you some copper. You should be able to weigh it. And then you should be able to tell me what the weight of the copper at the oxide at the end will be. Does that make sense? So I should be able to give you some copper. Say, burn it real good. Tell me how much it's going to weigh. You should be able to tell me how much it's going to weigh, and then you should be able to weigh it at the end. And if you did everything perfectly, what should you have? Exactly what you said you were going to get. Does that make sense? By the way, are you going to have exactly what you said you should get?
Probably not.
No, not a chance. And that's okay. You know, chemistry rarely works out perfectly. But does that make sense? Now we're ready for a lab. Because now we've gotten far enough into this unit that we're going to prep up. Hey, what am I going to give you tomorrow? Yeah, we're not going to do a lab, but tomorrow I'm going to give you the pre-lab.
Guess what? Tomorrow we're
We
doing.
have our lab books yet.
They're back there. They've been back there for days.
Really?
Days and days. Like a week. They've been back there for like a week. Would that be helpful? Yeah, I'll book it.
Sir, I almost call it Mr. Calvin.
You can go Mr. Calford, that's a compliment.
Mr. Science Man.
Mr. Science Man.
Mr. Science Man. I know we're getting way too formal here.
My dad is Mr. Science Man, thank you. No, that's not true.
Mr. Junior Science Man.
People always say that, but like nobody called my dad Mr. My dad's like a crazy hippie. He was just Joe. Still is. We said we want a computer lab tomorrow? Yeah, we can do that.
I did the combustion. Is that one right? I don't think that was.
Which one?
The top.
Looks good to me. What don't you like about it?
Is that... I don't know. It looks wrong.
Why does it look wrong? It looks good to me.
I don't like when people do that kind of stuff to a basic Shouldn't what you have, if I have 3.7 grams of ethanol,